Today we are going to study Chapter 7 of NCERT Class 5 EVS Experiments with Water. We are not only going to study, but we are going to do many experiments also. In this chapter, we are going to learn about objects that float and sink in water. Why do objects float or sink in water? Things float in salt water. Understand the term soluble, insoluble. Methods to dissolve things faster. Oil and water do not mix. Experiments recording the observation and interpretation. Separation by filtration. Concept of evaporation. Why some liquids move faster. Salt from seawater, Dandi March, and factors affecting rate of evaporation. So let us start our chapter, Experiments with Water. Aisha was waiting for dinner. Today Ammi was making her favorite food, puri and spicy potatoes. Aisha watched as her mother rolled out the puri and put it in the hot oil. She saw that at first the puri sank to the bottom of the pan. As it puffed up, the puri came up and started floating on oil. On seeing this, Aisha took some dough and rolled it into a ball. She flattened it and put it in a bowl of water. Alas! It sank to the bottom and stayed there. Now the question is, why do puris float on oil while frying? Puris float on hot oil because water in the dough evaporates on heating. Puri gets filled up with air. Puri swells up. The air being lighter than the oil makes the puris lighter and float on oil. But when Aisha flattened the puri and put it in a bowl of water, it sank to the bottom and stayed there. It did not rise and float. Why? Because she put the flattened puri in water, and the water in the dough did not evaporate. Puri did not swell up to become lighter to float. Instead, it absorbed more water. Think what would happen if Aisha put a puffed puri in a bowl of water. Would it sink or float? A puffed puri will float on water. A steel plate will float on water. Then a spoon will sink in water. And a cap will float on water. If we put a puffed puri in a bowl of water, it will float. You put a steel plate on water, would it sink or float? It will float. What would happen to a spoon? It will sink. Would the cap of a plastic bottle sink or float on water? It will float. In the evening, Aisha went for a bath. She had just come out when her mother called, "Aisha, you have dropped the soap in the water again. Take it out and put it in the soap case." Aisha was in a hurry and the soap case fell out of her hands. It started floating on water. Aisha gently put the soap in the soap case. She saw that the case continued to float, even with the soap in it. Have you seen that? Something float on water while others sink? Think how this happens. The poem here raises such questions. Why? Oh, why? A wooden boat in water will float, but a needle will sink. Why does this happen? Let me think. An iron ship will also float, though it's much heavier than my boat. But a needle, light as a leaf, thin as a pin, will sink right in. Why does this happen? Let me think. Come, let's find out why does this happen. This happens because of buoyancy, that is the upward force of water. Let us try to understand what is buoyancy. When an apple falls from a tree, where does it go? Naturally, it comes down to earth because the earth pulls everything towards itself. Now, what will happen if I drop the apple in water? The apple will try to go down, but the water also has a force which pushes the things upwards. This upward force of water is called buoyant force or buoyancy. Buoyancy or buoyant force is the upward force exerted by a liquid to oppose the weight of an immersed object. How do we know when an object will float or sink? Whenever an object falls in water, it occupies some space in water, and that much water is pushed out from its place, which comes up and raises the level of water. The water which is pushed out from its place is called displaced water. Now, the main factor is the weight of the displaced water. Please try to understand carefully. This is the main factor responsible for floating and sinking of an object. The buoyant force, that is the upward force, is equal to the weight of the displaced water. Less displaced water means less weight of displaced water. So less buoyancy, that is less upward force. But more displaced water means more weight of the displaced water. So more buoyancy or more upward force. So this is about the weight of the displaced water. Now let us come to the second important factor. It is the weight of the object. What will happen if the weight of the displaced water by two different objects is same, but the weight of the objects is different? Let us try to understand this. Here is an example of two balls of same size. One is iron ball and other is a plastic ball. Both are of same size, so both will push out or displace same amount of water from their place inside water. Let us suppose both displace 50 grams of water because the size is same, and we have learned that the weight of the displaced water is equal to buoyancy, that is the upward force. So the buoyancy is same for both. But what happens? Iron ball sinks and the plastic ball floats. Here comes the second important factor, that is the weight of the object. Here the weight of the iron ball is 500 grams and weight of the plastic ball is 40 grams. Here the weight of the iron ball is 500 grams and weight of displaced water is 50 grams. Here the weight of iron ball is more than the weight of the displaced water. When the weight of the object is more than the weight of the displaced water, then the object sinks. And in the next example, the weight of the plastic ball is 40 grams and weight of the displaced water is 50 grams. Here the weight of the plastic ball is less than the weight of the displaced water. So when the weight of the object is less than the weight of the displaced water, then the object floats. Since we have learned that the buoyant force is equal to the weight of the displaced water, so we can say in this way also that if the weight of an object is more than the buoyant force, the object will sink. And if the weight of the object is less than the buoyant force, the object will float. And if the weight of an object is equal to the buoyant force, the object will remain suspended. This is float, this is sink, and this is suspended. Now let us try to understand why a ship which is so big and heavy floats on water, but a nail which is so small sinks. Now look at this picture. This is the ship floating on water, and this portion shows the part of the ship under water. That means the ship has displaced this much water from its place. This is the displaced water. Every ship must be designed to displace a weight of water more than its own weight. The weight of this displaced water is more than the weight of the ship. So buoyancy is more than the weight of the ship, and the ship floats. The upward push of water increases with the volume of the object that is under the water. If there is a fault in the design of the ship and the opposite happens, that is, the weight of the ship becomes more than the weight of the displaced water, then the ship will sink. Now about the nail. The nail is very small in size, so it displaces very less water from its place. The weight of the nail is more than the weight of the displaced water, so the buoyancy is less and the nail sinks. Let us do some experiments and try to find out. An empty bowl, that is katori, floats on water. Now let's see what happens on putting pebbles in it. 1. It floats. 2. It floats. 3. It floats. 4. It's floating. 5. It's floating. 6. It's floating. 7. It sinks. A nail sinks in water. A matchstick floats on water. An empty plastic bottle with its lid closed floats on water. Now I'm going to fill it half with water with its lid closed. It's floating on water. Now I'm going to fill it full with water and lid closed. It's floating, but after some time it sinks. It sinks in water. An aluminium foil spread out floats on water. An aluminium foil made into ball floats on water. An aluminium foil in the shape of katori also floats on water. A soap case floats on water. A soap case with soap also floats on water. A soap alone sinks in water. An ice cube floats on water. Mark right for the things that float, mark wrong for those that sink. Now there are 3 columns. Things to be put in water. I guessed before I did it, and I saw when I did it. Empty bowl or katori. I guessed it will float, and it floated. After putting in 6 to 7 pebbles one by one, I guessed it will sink, and it sank. Iron nail or pin. I guessed it will sink, and it sank. Matchstick. I guessed it will float, and it floated. Empty plastic bottle with its lid closed. I guessed it will float, and it floated. Bottle half filled with water, it floated. Bottle full of water, I guessed it will sink, and it sank. Aluminium foil from medicine packing. Open and spread out, I guessed it will float, and it floated. Pressed tightly into a ball, I guessed it will sink, but it floated. In a cup-like shape, I guessed it will float, and it floated. Soap cake, I guessed it will sink, and it sank. Soap cake on a small plastic plate, I guessed it will sink, but it floated. A piece of ice, I guessed it will float, and it floated. After doing the experiment, fill in the blanks. The iron nail sinks in water, but the katori floats. I think this happened because the weight of the iron nail is more than the weight of the displaced water. The weight of the katori is less than the weight of the water displaced by it. Next, the empty plastic bottle floated on water. The bottle filled with water sank because the weight of the empty plastic bottle is less than the weight of the water displaced by it, and the weight of the bottle filled with water is more than the weight of the water displaced by it. The aluminium foil floated when it was spread out. When pressed tightly into a ball, it floated or may sink. This may happen because the weight of the spread out aluminium foil is less than the weight of the water displaced by it. The weight of the aluminium ball is also less than the weight of the water displaced by it. It may sink depending on the aluminium foil of the medicine packaging. Is it magic? Take some water in a glass, put an egg in it. Now keep adding salt in the water, half a spoon at a time. What happened? The egg sinks in plain water, comes up in less salt, and floats in much salt. Why do you think the egg floated in salty water? Egg floated in salty water because on adding salt, water becomes heavy and the buoyancy, that is the upward force, increases. There is a sea called Dead Sea. All oceans and seas have salty water. The saltiest of all is the Dead Sea. It is so salty that animals and plants cannot survive in it. That is why it is called Dead Sea. The most interesting fact is that even a person who does not know to swim will not drown. He will float in water as if lying down on it. These are the pics of persons floating in Dead Sea. I'll show you a video of a person floating in Dead Sea.
supposed to be able to float. You can see the salt. And on the rock, there's also salt on all of the bottom of the sea. See? It's all over my fingers. So they say you're supposed to like bend down and lean back because the rocks are quite sharp here. And you'll float.
Вот так прямо искупаешься.
Just sleeping in the water. I feel like I'm floating down the river, but there's no inner tube. It's like there's no current. I'm just above the water, no inner tube.
Okay.
If you laid on top of me, you think I'd sink?
With my weight, yeah.
You got a newspaper for me or something to read?
Now, why a person who cannot swim will not drown in Dead Sea? Do you remember floating an egg in salt water? Dead Sea is saltiest of all seas and oceans, so its density is very high. That is, the water of Dead Sea is very heavy and the buoyancy, that is the upward force, is very high. So a person who cannot swim will not drown in Dead Sea and float on water as if lying down on it. Now let us try to find out the location of Dead Sea. This is world map, and here is India, this is Pakistan, Afghanistan, this is Africa, this is Saudi Arabia, and here is the location of Dead Sea. Now we can see in this map also, this is Egypt, Saudi Arabia, Iraq, Syria, and this is Dead Sea. A more close-up view. This is Egypt, and this is Israel, and this is Jordan. So Dead Sea is between Israel and Jordan. You can see in this also Egypt, Israel and Jordan. In between Israel and Jordan, this is Dead Sea. We have learnt about floating and sinking. Objects that float and sink in water. Why do objects float or sink in water? Things